this part I would like to talk about the evolution of the Earth and indeed the evolution of celestial bodies. The core is essentially a space, and it is a space where very, very tiny particles collect. And the denser this space is, the finer the particles that collect there, and hence the more mass can collect in the core. And since the structure of a celestial body implies that the majority of particles collects inside of this dense core, the volume of a celestial body is not indicative of its mass. When we compare the size of Jupiter with the size of the Earth, then we realize that Jupiter is much, much bigger. Now, according to scientists, Jupiter also has a much bigger mass. However, I think we need to think about that. If this is the Sun, which is much, 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 much bigger than the Earth, and much, 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 much bigger than Jupiter, but also much, much more denser, and therefore the particles that reside in the core of the Sun are so infinitely much more tiny that there's no chance that any of those particles are likely to get stuck inside of the core of the Earth or inside of the core of Jupiter. And if we just take this sort of scale of the Sun, the Earth and Jupiter painted here on this wall, then in relation the Earth should be 115 meters away from the Sun. 115 meters, the Sun being about a meter in diameter. Jupiter should be some 570 meters away. So there's almost like a distance of 455 meters between Jupiter and the Earth. This is how much further Jupiter is away from the Sun. An enormous amount of distance. If Jupiter had more gravity than the Earth, if Jupiter had more mass than the Earth, if it represented a denser space to tinier and finer particles than the Earth did, then more of these particles would collect inside of Jupiter. More exchange of particles would happen between Jupiter and the Sun, and in theory, the gravitational force between the Sun and Jupiter should be so much greater that Jupiter should be much closer to the Sun than the Earth. The fact that Jupiter is so much further away from the Sun seems to indicate that Jupiter is far less dense than the Earth. Now we know that the surface of Jupiter is made up of gases. We can see these gases move. The Hubble telescope sends wonderful images of that. The question is, how far do these gases actually go towards the core of Jupiter? You see that there is a possibility that there's only very tiny, dense core to Jupiter, and that the rest indeed is just gas. And there's some argument for this. Firstly, the distance that Jupiter is away from the Sun. But the other argument is, if indeed there is this stream of dark matter between the Sun and the planets, and that the fact that we do see the planets is because some of the coarser particles actually get stuck in trying to condense into the core, and as a result of them getting stuck, we see what we call mass. We see the formation of mass, because they are, as it were, in a bottleneck situation. If that is the case, then it is quite possible that over time these cores of the planets get denser and accumulate more mass. And over time this could mean that the mass of the core, or the density of the core inside of Jupiter, reaches a critical point as Jupiter gets closer and closer to the Sun, where at some point these gases get pulled into the core and liquefy. So we may assume that when we look at our solar system, we're looking at Pluto, at Neptune, Uranus, at Jupiter, the Earth, Venus. We may look at it and think that maybe what we're looking at is a life cycle, a planetary life cycle, the evolution of planets. Perhaps we can track the evolution of a planet here. We're looking at Pluto. Very fringes, there are some rock particles which are not very dense at all compared to the core of the Earth, which are just about starting to interact with energy that's emitted from the Sun. And they're growing, and they're gaining density, they're feeding on the Sun, that energy. That energy is trying to move through the core of Pluto. And eventually, these forces will get strong enough for these loose parts at the moment to gather and form a planet. with one solid core. And then that will grow. And as it grows, Pluto will come closer and closer. And it will start to form gases. As the hot rocky core starts to shape, these gases start to form. The bigger that core gets, the more gases are emitted when we look at Jupiter. This is sort of like this zenith of gas formation, and it has an enormous size. But at some point, traveling between where Jupiter is now to where the Earth is now, those gases may collapse as the critical mass inside of Jupiter increases. And this may have happened to the Earth in the past. So it is quite possible the water, the oceans, were actually, like Jupiter, gases that were going around the Earth. And we may even think that even at that time it might have already been possible for some bacterial life forms to exist in those gases. So that when finally this dense and hot rocky core had grown to a point where the surface of it was starting to cool sufficiently not to turn these gases into gases anymore, but to allow these gases to cool down, at that point we would have had the original formation of the continental plates, the original crust, which today are those parts of the planet which protrude above water, and the oceans would have formed. And indeed, at this early stage of the Earth, there may not have been any land. The Earth may have been entirely covered in water. It may only have been 400, 300 million years ago that the Earth mantle had grown to the size that started to push through the water. And it is only then, of course, that we start to see life on Earth. And this may also explain why dinosaurs, why in these periods we had such enormous animals compared to today. Because the gravitational force of the Earth may have increased. So that when we look at the skeletal build of a Tyrannosaurus rex, and we think, wow, this animal today would weigh 9 tons, yet the bone structure is almost like that of a bird, really light. I mean, surely that animal would have to just trudge along like this, but then you have paleontologists who say, no, this animal looks like it's been leaping around in the air and was actually really agile. There were dragonflies with a meter wingspan. Their genetic makeup may not have changed at all. It's just the gravitational forces which are pulling on the skeletal system of these dragonflies. That has changed, and it dictates how big these dragonflies can get today. And we may look at Venus and we may say, well, maybe there's going to come a point when the core of the Earth is becoming so dense that just as the gases at some point were pulled to the surface of the Earth, the oceans of the Earth will be pulled inside of the Earth as the Earth becomes so much denser. And this is why Venus again is so much closer to the Sun, because it is so much denser. And we may muse that at some point every planet eventually will get sucked into the Sun and will actually plunge into the Sun and become part of the Sun. And we may even go a little step further and say that the black spots that we see on the Sun may be an indication that this is where this has happened. And this significant increase of mass and density at that point where the planet fell in is responsible for the incredibly dense light that is emitted at that point, which is therefore not visible to us. It's dark matter, dark light which is being emitted to a tiny, 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 tiny particle that can penetrate the surface of a celestial body. The core and inside of a celestial body represents a much vaster space than the huge void that we perceive when we look up into the stars.